Okay, in this video we're going to just solve what time Abeam problem. So it looks a little similar to the course to steer, except the big difference here is we're not asking for a course, they're asking for an ETA. So as soon as that happens, I know from experience that this is going to be a Pythagorean theorem problem, but let's just go ahead and draw out what's going on. We're steering like 031. That's great. There's a light picked up dead ahead. 0017. Okay. And there's my light. Okay. On my bow. And they said that light was 12.7 miles. Okay, great. And now I want to pass that light, Abeam, by about 3.5 miles. So I draw a circle here that has a radius of 3.5. Okay. And now the question is, okay, if I go to this side, that's going to be on my port beam. I don't want that. They said we want to be on the starboard beam, so I'm going to go like this. That's going to be starboard beam. So this is the diagram that I want here. I don't really actually need that, but I'm just going to go ahead and we'll draw the diagram according to what is given. Now remember, a beam means that it's going to be 90 degrees to my course. So that means that's going to be right there. That's where the right triangle is, okay? It's very important to get your right triangle in the right spot. Your right triangle is never going to go between, the right triangle is never going to be actually at the light. It's always going to be between your course and the light. Okay, very important. Don't put that in the wrong spot, otherwise you're going to have the wrong relationships. So this is now 3.5 here. Okay, now I know this leg, I know that leg, and I want to know this leg. Okay, so that's a right triangle. Now I can use Pythagorean theorem because it's a squared plus b squared equals c squared. So the two sides squared equal the hypotenuse squared. So here's my hypotenuse. So if I was to say that this was A, this was B, and this was C, okay, then I'm going to go A squared plus B squared equals C squared. So A squared equals C squared minus B squared. I subtract that. And then A is the square root of C squared minus B squared. So now I just got to do some math. And that's going to give me that leg. So A equals 12.7 squared minus 3.5 squared, and I got to square root that whole thing. So I'll bring my calculator over here now. All right, and I'll clear. And I'm going to go second square root, and I'm going to go 12.7 squared minus 3.5 squared, okay, and equals, and I get 12.2. So the length of that leg, A, is 12.2 nautical miles. Great. So I've done step one. Now I'm going to do step two. Okay. Well, to do step two, I got to do my speed times time equals distance. So distance equals speed times time. Okay. And I want to solve for time. So I'm going to divide by distance. So time is distance over speed. Great. So in this case, that's going to be 12.2 divided by 11. Okay, and that gives me, so let's do 12.2 divided by 11. Oh, shoot. 12.2 divided by 11 is 1.1. Okay, 1.1. Okay, 1.1. Now that is in hours, because this is just nautical miles per hour divided by speed. Okay, okay. Nautical miles divided by nautical miles per hour. This is in hours. Great. So hours. That's hours. I don't know if you can believe it or not, but that was the word hours right there. Okay. Now, what was my original time? Well, my original time was 0017. So that 1 hour goes here. Remember that this is hours, this is minutes, okay? One of these is 60 of those. So that 1 comes there. Now I got to convert the 0.1 into minutes. So to do that, I'm going to take 0.1, I'm going to times it by 60, and that gives me 6. All right? So that's 6 minutes. And so now I will add that over here, 06, and that gives me 0113, and that is the time I will be Abeam.